Most likely our final example of arc length here, and yeah, so this problem I thought was interesting because of the function given here. The function is given as the integral of some other function, right? So yeah, but you know, it's still a function of x, and on 0 to 3 we're still talking about an x interval. So we'll still have to use the formula that we derived in example 0 that said that the arc length is L equals from the integral from a to b of, and then it's going to be square root of, and it is 1 plus f prime of x all squared dx, yeah? Okay, cool. And since f of x is right here, f prime of x is going to equal, by the fundamental theorem of calculus, right? It's going to equal square root of x squared minus 1, right? I don't know why I wrote it on the next line. I guess we could have fit it in here. But yeah, square root of x squared minus 1. And again, I know that this is f prime when f is this because of the fundamental theorem of calculus. And this is just the interval over which we're supposed to find the arc length, so not part of the definition of f. Anyway, yeah, so here's f prime. So that's pretty straightforward then, you know, because at this point we plug into our arc length formula and we find that L, I guess I could start writing here, will have to be the integral from 0 to 3 of, and then it's square root of 1 plus f prime of x squared, but we get the 1, and then plus f prime is root, ooh, that was slanted. Now you see why I use a ruler. Root x squared minus 1, and then we square it, dx. So L is equal to the integral from 0 to 3, to 0, of root, and inside we have 1 plus x squared minus 1, right? And that's just x squared. So square root of x squared, which is technically the absolute value of x, the square root of x squared. But on the interval 0 to 3, we could just say it's x. And I've assumed something like that in one of the previous examples, by the way, which is a safe assumption to make. So here, x and then dx. So this could not have been easier, right? Okay, so here we find that we just have x squared over 2 integrated from 0 to 3. And so 9 over 2 is the value of the length of the arc on this curve, on that function, from x equals 0 to x equals 3. Yeah? Cool. All right. Hope you enjoyed these videos, and yeah, keep watching. Take care.